Okay, we're going to try to fix each one of the problems that we don't have a 6 on. And so on problem number 1, what I was looking for is this is the correct answer on the AP Central practice test that we kind of did. And I took a picture of it, and then this was, I don't know, answer C or something like that. I'm asking you to show me how does this definite integral transform into this definite integral? Well, this is x equals 4. This is x equals 1. And so if we plug 4 and 1 in for x right over here, we get u, right? So when x equals 4, okay, u equals the square root of 4. So u is 2. I'd like to see that kind of work, right? When x is 1, when it equals 1, then u equals the square root of 1, or u is equal to 1. So that's where these numbers come from. So check mark, check mark. I showed where the limits change, right? Now, where does this 2 come from? Well, if u is equal to square root of x, du dx would equal, let's see, square root of x is the same thing as x to the 1/2 power, right? And we're taking the derivative of it. So the derivative power rule is bring the half down out front, so 1/2, and then we would get x to the negative 1/2. You subtract, 1 from the exponent. So if I move the dx to the other side, now I've got du equals 1/2 x to the negative 1/2 dx. Okay, well, look at this. Right down here in the denominator, I have an x to the 1/2, and because it's in the denominator, see, that's the same thing as having 1 over 2 square root of x. That negative means the square root's in the denominator, dx. So I have almost what I need. I mean, I just need a 2 right down here in the denominator, and then we could link up this denominator with dx and replace it all with du. Okay, so I'm showing that I'm going to replace it all with du right here. I'm kind of circling that. But if I put a 2 in the denominator, I got to put a 2 in the numerator out front, or just a plain old 2. So that's where that 2 comes from. The 2 comes from the fact that we're introducing a 2 in the denominator. So the 2 out front is going to cancel out. It's going to cancel out the 2 that we're putting in the denominator. Cancel out the 2 that we're, introducing, like I said, in the denominator. So I wanted to see some of this work, that you're showing the u substitution, how the limits change, and then how you get rid of dx and make it a du by doing this work right over here. All right. I'm going to go over every problem on the test, and if I don't make one of them clear, call me over as you're watching this video. All right. On this guy right here, this really, because, if we were looking at making this u, let's say u equals x plus 1, well, du would be just 1 dx. So there's really no need to substitute a 1 here, like introduce a 1 and make this u. This is just almost as good as having just x to the 1/2 power. So how do I do the power rule for antiderivatives? Well, on the power rule for antiderivatives, we raise the power by 1. So if I raise the power by 1, that becomes 3/2. And then I divide by that new power. So I'm dividing by 3/2. And so I get that. I mean, that is the right answer, but it doesn't look all that good with a fraction in the denominator. So you multiply by the reciprocal, right? When you're dividing by a fraction, you multiply by the reciprocal of that fraction. And we end up with this idea. Okay, so I think that's as good as it's going to get. Maybe somebody would argue that you should do the square root and all that stuff, but I think that's fine. On number 3, I'm just going to check my key here real quick to see what I had on number 2. Thanks for being patient with me. Something seems different right now for whatever reason. It's been a couple days since I've looked at it. Oh, well, yeah. I mean, I've got limits on that thing. I'm not done yet. That's why I'm like, wait a minute. We didn't leave it like that. Yeah, we got 0 to 3. I'm sorry. So it's not an indefinite integral. I forgot that there's some limits on there right there in front of my face. I didn't see them. So we got to put a little bar. we got to put a little bar at, let's put a little bar at the end of our, oh, that's a big thick bar. And let's put the limits there. So 0 to 3 is what we want to evaluate, right? 0 to 3. So if I stick 3 in here, I get 4, right? So I get 2/3 4 to the 3/2 power. And I'm going to subtract what I get when I do the 0 in there. And that would give me 1 to the 3/2 power. Okay, well, that one's easy. That's 1, that's 2/3. Okay, so I get 2/3 right there. This one, the 2 in the denominator means the square root of 4. So that's 2. And then when I cube it, I get 8. And when I multiply 8 times 2, I get 16. So I get 16/3 right here. So 16/3 minus 2/3 is 14/3. That's right. I was looking for this answer, 14/3, not just the indefinite integral. My bad. Hey, if I let u equal x squared, du equals 2x dx. So I need a 2 right here. I need a 1/2 out front. So my integral has now become 1/2. And also I'm moving this x right over there so that all of the dx can become du. So I've now got du here, and I've got e to the u there. Antiderivative e to the u is just e to the u. So I'm going to put down e to the u, but I'm going to substitute back in what my u was. My u is x squared, so I get that. And then I'm going to evaluate it from 0 to 4. Okay, so what do we get there? We get 1/2. We got e to the 16th power minus, let's see, when I stick 0 in there, I get a 1, right? Because anything to the 0 power is 1. So I think that's probably a good way of writing the final answer. Number 4. Okay, so when you're taking the derivative of an antiderivative, they kind of cancel each other out. And what I mean by kind of cancel each other out, well, the upper limit is x squared. So it's another function. This is like the inside function, okay? And this whole thing is kind of like the outside function. So in the chain rule, if we take the derivative of the antiderivative, these two kind of cancel each other out, and we get the outside function, natural log of the cosine. But we are sticking in this x squared, okay? We are sticking that into the antiderivative, okay? And so here's the derivative kind of the outside function, but there is also an inside function that we need to take the derivative of, and that becomes 2x. So we should have 2x natural log cosine x squared. What about plugging a constant in? Well, if you had a constant in there and you took the derivative of the inside function, it's going to become a 0. So we don't have to worry about the constant lower limit, but we do have to worry about the upper limit right there. So this is my final answer. I'm just going to, again, check my key. Yes, that's exactly what I have written down on my key. And we can talk more about it. I know in class we talked about, calling this thing like f of x, and then, we're going to put f of x squared, and then we're going to take the derivative of that f of x squared, but I'm just going to leave it at that for now. Okay. Let's see, where's number 5? Here it is right here. Okay, so 5 is, do you know what the antiderivative of 5 to the x is, right? There's no work to be shown here. This one is 1 over the natural log of 5 times 5 to the x. If it was an e to the x, it's just e to the x, because 1 over natural log of e is just 1. And then it's an indefinite integral, so we're going to put plus c on the end. And let's see, number 6 is up here. So 6 wanted us to do the antiderivative of 1 over t. Okay, the antiderivative of 1 over t is the natural log of t. We should probably have absolute values on it. And we're going to evaluate that from 1 to x. So I get the natural log of x minus the natural log of 1. Obviously, I don't need absolute values on a 1 there. The natural log of 1 is 0, because what do I raise e to get 1? 0. So my final answer is natural log of x. Now I just put some derivatives on here. You could redeem yourself for the Chapter 5 derivative concepts if you got these right. So I'm going to hand back the Chapter 5 test. If you got both these right, a 6, I'll look through the derivative one on number Chapter 5, and I'll give you a 6 on that. So we got the product rule here. And the product rule means I take one function x to the 1.4, and I multiply it by the derivative of the second function, which would be 5e to the 5x. Because of a chain rule, the inner function being 5x, I got to take the derivative of 5x. That's where that 5 comes from. And e to a power, e to a variable is just e to that variable. So that's the first part. Then the product rule says plus the derivative of that first function, 1.4 x to the 0.4, bring the power down, reduce the power by 1, and then leave the second function alone. Okay, boom, there's my product rule. And the last one on here is a chain rule problem. So if I'm taking the derivative, here's like, let's call this layer 1, and then here e to a power is layer 2, and then the sine function is layer 3. I've got to have 3 things over here all multiplied together if I'm going to do the product or the chain rule correctly. Okay, so layer number 1, what's the derivative of negative 2x? Okay, that's negative 2. Okay, layer number 2, what is the derivative of e to a power? Okay, well, that's just e to the power. Okay, and you leave the inner function alone now. I'm taking the derivative of this second layer, and here it is, e to the negative 2x. You don't do that derivative again. We've already done that derivative. That inner function's right over there. What's the derivative of the sine function? Okay, that's cosine. And the chain rule says leave everything inside alone. So I got e to the negative 2x power. So I'm going to check my key, make sure I've got all that stuff. There's my negative 2. There's my e to the negative 2x. There's my cosine of negative 2x. So these last 2 problems being derivative problems, they were both worth 6 points. So let's go through my scoring. I have a 6 out to the side here. Number 6 was worth 6 points all by itself, because this is more of a focus of what we're doing right now. What is the antiderivative? Over here, this one right up here, number 1 was worth 6 points. Okay, so this one's worth 6 points. Number 2 and 3 together was worth 6 points. And then we have number 4 down here was worth 6 points. So this one was worth 6. And then number 5 is worth 6 points. Okay, please do your corrections in a different colored pencil and then turn it into me for a 10% raise. I did follow the 6-point rubric system. So I'm going to show you what that looks like if you want to pause the video and kind of study what number did you have at the top of your test. And let me see if I can zoom in on that here so maybe you can see a little bit better. So like if you had a 32 at the top of your test, I put 93%. If you had a 31, I put 91%. So I truncated all the decimals, and then you're getting the 10% raise. So it kind of takes care of that rounding or truncating issue. If you have any questions about the rubric, let me know. The lowest score I put on somebody's test was a 60%. I didn't go below that. So like if you had a number below 18, I'd still just put a 60%. So if you do the corrections, I'll put a 70% in. I know that may not be satisfying to you. You wanted a higher percentage, but on the next test, we'll have more antiderivatives, more derivatives, maybe another Riemann sum that you could show me that you understand the Riemann sums now, and we can go back and kind of backfill some gaps that you have in previous tests. Thanks for your effort. I do expect everyone doing at least a half an hour of homework every night. Please don't forget that, and come in during advisory if you want some extra help.